Oh, Lexi, I didn't see you there.
Hey, how are you doing?
I'm okay. I'm
Working
working
on
on
some
this. Yeah, I'm working on this integration by parts problem, and I'm really stumped. I was wondering if you could help me out.
Yeah, sure. Do you want to do it on the board?
Sure, that
Okay.
sounds great.
Let's do that.
Okay. So this is the problem that I'm using, and I assigned my u and my u prime, and my v prime and my v. And so when I plug it in, I get the integral of e to the x times cosine of x times dx equals e to the x times sine of x minus the integral of e to the x times sine of x times d of x. So I put this last part of the equation in a different color because this is where I get stumped, and I was wondering if this is where you could help me out. And I'm really stumped because when I went to reduce it, it basically just goes in a circle, and I don't really understand the logic of this and how I would go about solving this. So I'm wondering if I can get your help.
Okay, so the reason this part of the equation doesn't reduce is because when you take the integral of e to the x, you just get e to the x, and the integral of sine x is negative cosine x. What you want to do is you want it to somehow reduce to 0 or 1, which this doesn't do because the trig functions just go into a circle. Since this part of the equation just goes in a circle and never ends, we're going to use a different method called the going in a circle method. What we do is we're going to take this equation and redo it with the same formula. So it's like doing the equation 2 times.
So now that I have to redo the problem, I have to rewrite the example and reassign my u and my u prime and my v prime and my v. And now that I have replugged it into the formula, what do I do next?
Okay, so what you're going to do, now that you redid the equation and this is what you ended with, so you're going to go back to the original problem we started with when we took the integral of e to the x cosine x. When we did that equation, we ended with the integral of e to the x cosine x dx equals e to the x sine x minus e to the x sine x. This part used to be e to the x sine x. And that's why we redid it, because we couldn't reduce it. So we take what we got when we redid the equation, and we're going to substitute it at the end of the problem, like here. So the next thing I did after I substituted this part into the equation, I looked at the equation and I saw a similarity on both sides of the equal sign. I saw an integral of e to the x times cosine x on this side, and I saw an integral of e to the x times negative cosine on this side. So I thought that I would try to distribute this negative side outside of the e to the x so I can get them more similar. So what I did is when I distribute the negative sign, this becomes positive cosine, this becomes positive cosine, and this becomes positive. So now that I made the similarity of having integral of e to the x times cosine on both sides of the equation, I'm just going to do a basic algebra problem, like solving for x, but in this case, solving for the integral of e to the x times cosine x. So what I'm going to do is I'm going to come back over here, and I'm going to add this part to both sides. So this would end up being 2 integral of e to the x times cosine x. And that would just equal this equation on this side, which would be e to the x times sine x plus e to the x times cosine x. And now, since we have 2 here, I'm going to divide it by 2. So this would just become the integral of e to the x cosine x, and divide this by 2 as well, and that would be our answer.
Thanks, Lex. I really understand it now. So all I have to do is take the part of the equation where I got stuck on and replug it into the original formula for solving integration by parts. When I have that answer, I just substitute it into our first equation at the part where I get stuck and then simplify it like a basic algebra problem.
Yeah, that's exactly right, Emily. Good job.
Sounds good!